Again, I'm Emily for the recording. Um, okay, shall we get started? So I posted some things, so I'm way behind on what I kind of wanted to do. I've had vertigo for like the past week. It's getting better now. Um, but when I move my head, everything's just my eyes just kind of like bounce around after. It's really annoying. It's kind of dizzying all the time, but like I said, it's getting better. So not as organized as I want it to be, but we'll get there. We'll get there. Okie dokie. So, um, like I said, if you have any questions, feel free to put them in the chat or just kind of pipe up. I might get startled. uh, as I think David knows, whenever someone says, "Whoa, what?" um, all right. So first things first, let's go through the course outline, but I'll also take you to our Moodle page, which is kind of a work in progress right now. Everything that you might need from the course outline, I like to have at the kind of the top on your Moodle page. So my contact information, you can email me. My cell number is also on there. Feel free to text me if you're working on a problem. I always feel like emails, for some reason, you have to sit down and you have to kind of think what you're going to write, and it just can take a little bit longer. And so to avoid that, I'm totally fine if you're just, you text me and you say, as long as you introduce yourself once, so I know who I'm talking to, ideally, then I'll save you in my phone, and then we can just kind of chat kind of normally. But what I find is if you're working on a problem, then usually the easiest thing for you to do is just to send me a picture. Hey, this isn't working. Where am I going wrong here? And then I can do the same, right? I can work out the problem or kind of mark up the picture that you sent me and send it back, and we can kind of just work through problems that way. And so we'll be able to work through problems quicker that way if you're working on your own. So feel free to text me. People call me sometimes. My ringer is never on unless I'm expecting like an important phone call. So just, I'm probably not ignoring you. I'm just, my ringer is never on. So just text me, and I'm an adult. I can answer when it's appropriate. If it's so, one thing I don't want you to worry about, oh, I'm sending this too late or too early or whatever. I can decide when it's appropriate for me to respond, and so and don't worry about that. Just if you have a question, just send it right away. For office hours, I decided on kind of earlier in the week, so Tuesdays and Wednesdays between 12 and 2, and I'll just be here in the Zoom room. If you have any questions, you can pop in. So that is today, I guess, after our class, but also yesterday after our class. Don't worry, no one came, which is probably a good thing in the first week of classes, that no one has any burning questions. But anyways, usually I just have my camera. I'm here in the Zoom room, but if my chair is empty, I'm probably just in the kitchen, just right there. So just kind of make yourself known if you come in and I'm not here, and I'll come back. Otherwise, it's 2 hours of me just sitting here. Usually I have work to do, so it's not a big deal. But and of course, our classes are Wednesdays and Fridays. What a weird setup, but pretty good time, right? Not too early. Well, sort of early, but ending before noon. So yeah, comme ci, comme ça. Okay, so The grade breakdown, it's very spread out. Okay, so none of the things that we do are kind of high stakes, except for, I guess, the final exam. But even the final exam is only 25% of your grade. So all your grades are kind of spread out, which is nice. But there's a lot of things to stay on top of. So you should be registered in a lab. And I made a note on our Moodle page, but just so you know, there are no labs in the first week of classes, and that's always true because there's no material that's been covered yet. So labs will start next week. Um, and typically, and you'll have to talk to your lab instructor, and you might be in different labs. It doesn't really matter which lab you're in, as long as you're in a lab. But typically, if we have a day off, for example, Easter Friday, Monday, kind of early April there, typically if there's a holiday in a week, then there are no labs that week, but you'll have to check with your lab instructor just so you're not thrown off by that. Because if there are Friday labs, for example, and the Friday's off, then it screws up the whole schedule. So. But the labs are kind of none of my business. I've taught the labs, so if you have lab questions, then for sure you can send them to me. But it's been a while since I used Maple, so they might have changed stuff, and just kind of talk to your lab instructor instead. For assignments, we're going to do assignments. They will be in Webassign. So what happened yesterday, or kind of, I set up my Webassign for my pre-calculus course, and for some reason, something happened. It wasn't working. People weren't able to log in, so I had to contact Webassign, and I just got word this morning that they fixed it. So I haven't set ours up yet. I will, no rush. I'll put the information on our Moodle page. So if you've used Webassign before, maybe in pre-calculus or whenever, then you might be able to log on, but otherwise we'll go through it on Friday once I have it all set up. So no rush. But we'll do assignments in Webassign, but also quizzes in Webassign. So we're going to have little end of the week quizzes, and we're going to have them on the Fridays. Okay, there's kind of a blurb that we'll go through in the course outline, but they'll be worth 15%. So not very much each individual one, but a little chunk of quizzes. Okay? And that's just to make sure that you are kind of staying on top of the material and are able to do these problems with a time constraint. Okay, and it'll be during our class time. We've got 3 tests. Okay, I kind of did them. So I was trying to figure out good timing for the tests. I always like to have tests before reading break, because then you can be math free for a reading break, which is always nice, and not be reading for reading break. So that's what I like to do. So I tried to kind of condense everything in chapters 1 and 2 before reading break. Now, chapter 1 is essentially just a review of pre-calculus. And I guess some calc teachers don't even do chapter 1, but I think that's kind of unfair, because I want us all to be on the same playing ground. So I'm just gonna go through chapter 1. We've got time, so why not? But then essentially test 1 is after chapter 2, test 3 is after test 2 is after chapter 3, that's confusing. And then test 3 is after chapter 4. Those will be individual tests, and then the final exam will be cumulative during the final exam schedule. So it'll be all the material that we've covered. But I just landed on a schedule that I'm feeling comfortable with. And what I'll do is, I'm trying to scroll on my shared screen. It doesn't work like that. What I'll do is, like I've done for this week, I'll do for every week so that you have an idea of where we're headed each week. Okay. But like I said, I haven't had time to get that organized quite yet. All right. So I posted an announcement last night. So hopefully you got that. Make sure that you're getting announcements because that's how I'll try to reach the group. There is the Zoom classroom link. You're here, so you made it. Great. And then I tried, this is my first time making a playlist on YouTube. I'm not a very good YouTuber. But so I tried to make a playlist. Hopefully it'll work out. Or you can just go to my channel and find the playlist, hopefully. I don't know. Who knows? Let me know. All right. So let's just flip through the course outline. Same information here. Like I said, on the Moodle page, I like to have everything that you need from the course outline, but just so you're aware of everything that's in here. It's got our class time and transfer information. They just changed the edition. So, and I don't even have the textbook. I have the ebook, but and I think I have the 8th edition. But as far as I could tell, no sections were changing. But we'll be using the 9th edition for the Webassign. The Webassign should be $99. Now let me write that down for you guys here. So welcome to Calculus. One. Presumably you're going to do Calculus 2 as well, Calc 2. And what's nice about the Webassign that you purchase is it'll cover Calc 1 and Calc 2, and I think even Calc 3 if you wanted to go that far, which I encourage you to do because it's pretty fun. So Calc 3 and Calc 4 are basically just redoing Calc 1 and Calc 2, but with more variables. So if you like that kind of, oh, I know what I'm doing, it's just a little bit harder feeling, then I would encourage you to think about doing Calc 3 and Calc 4 as well. But anyways, that's down the road. But yeah, so you use the same textbook for Calc 1 and Calc 2, so you have access for, I think, 3 terms, however you use them. We will use Webassign. Which includes the ebook. So you don't have to buy the physical textbook. I know it's crazy expensive, and you probably won't use it anyways, if you're anything like me as a student at least. Now that I'm teaching, I want the textbook, but when I was a student, I was like, no. So we will use Webassign, which includes the ebook. And it should be $99. I'm pretty sure $99 in the bookstore, or in the online bookstore, I should say.
I got it for $99.95. Yeah, that's what my receipt is saying.
Perfect. $99.95. Just under the $100 mark. I'm sure they did some sort of survey and they were like, how much do you think a textbook should cost? And the answer was less than $100. They're like, got it, $99.95. So you don't have to buy the access. So once I set it up, you'll have 2 weeks for free. So I encourage you to use that free trial because you'll have to make an account. And then if you decide to leave the course or whatever, or kind of hold off, then you don't have to buy the access right away, right? And once you've made your account, if you buy the access to it, like once the free trial is done, um, all your answers and stuff will just transfer over to the paid account. So don't worry about that. So use the free access for the first 2 weeks. And hopefully I'll be able to set it to say that we started today or maybe even tomorrow. And then the 2 weeks starts after that. So you'll want to use the free access until you're sure that you're going to stay in the course, and then we can go buy the access and have you in the course. Okay. You will be able to use this access for Calc 2 as well. So that's good. Okay, so let's go back to I've got the course outlined here. Okay. So I can't remember if I talked about it off the recording, I think. But these notes that I write here, I will post on Moodle after class. And then the recording of the shared screen and me blabbing, I'll post on YouTube, and the link is there. Hopefully in a playlist, like I said, I don't know. And so you'll have access to everything. So I know a lot of people learn best by just kind of sitting back and listening instead of trying to frantically write everything down. And so I'm trying to kind of accommodate all styles, but who knows? All right, so you'll need a calculator. Totally fine to use an app. We're online after all. So I'll be using Desmos. So Desmos is a free app. It's a free graphing calculator is kind of how it started. And then they decided to do just a scientific calculator. So these green apps on my screen here. So I've got Desmos, which is the graphing calculator, which I like to use quite a bit, just to kind of see how what a function looks like, right? If I'm doing x squared, it's nice to know what that looks like. I can do multiple functions on the same graph, 2x minus 1, for example, right? Things like that, straight line. And so we'll use Desmos, and just for kind of completeness, if we need a calculator, I'll try to use this Desmos calculator, 14 divided by 3, and it'll give me the approximate answer. But also if I hit the square over a square, it'll give me the exact answer as in simplified form. So it's got all that going for it. Pretty decent. We don't need a fancy calculator, but whatever calculator you're used to, right? And of course, some sort of computer, not even necessary. Well, probably for the labs, you'll need a computer. Just a device, it should say, with access to the internet. But you're here, so you managed. So we're going to go through the majority of chapters 1, 2, 3, and 4 for this course. There are a couple of sections that I've cut. They're optional. And so some of them I just kind of, in the interest of time and to be able to do chapter 1 as well, I just cut, for example, 3.8. It's okay. And 4.6, for example. But otherwise we're going to do, and we're just going to go through in order. And we're using Stewart. Stewart is kind of this calculus rock star, and he's got these really great textbooks. We use them for pre-calculus and also for calculus, and so he does good work. So that's why we can just follow the textbook instead of just jumping around. All right, so we're going to work through. We'll have test number 1 after chapter 2, and here we'll have test number 3. And then here, we're going to cut and do test, oh, sorry. I keep doing that. Chapter 3 is test 2. Chapter 4 is test 3. Ugh, hard to say. Okay. So test 1 definitely has a lot of stuff on it, right? But this here is mostly just pre-calc. Okay. So we'll go through it, but should be review, so it should feel pretty good. Okie dokie. So we've got the learning outcomes on here. Usually learning outcomes don't really make sense until the end of the course, but it's a really good kind of check-in point if you're studying for the final exam, for example. Then you can refer back to this and say, oh, well, here are all the things that that I'm supposed to be able to do on the final exam. Sometimes these bullet points are vague, but for the most part, you know, you should be kind of going through this list and saying, oh yeah, I know how to do that. I know how to do that. So, but in the beginning of the course, it doesn't really make sense. So, I put a note about the class structure just because with online, everyone's kind of doing their own thing. So I just wanted you to know how we'll be doing things. We'll have lectures during class time here in Zoom, just like we're doing now. And then I'll post the notes and then I'll post the video, but it takes a little bit for it to process. So it'll be posted later in the day. So, you know, if you can't make it to class, then watch the video, but it won't be available for a little bit. And then the note about, well, if you speak, it'll be recorded. And if your camera's on, it'll be recorded as well. So we're gonna have, quizzes. And there's more on that after. I guess I moved some chunks around. But every Friday, we'll have a brief 45-minute quiz, right, during class time. So it'll be at the beginning of our class time, we'll have a 15-minute kind of buffer zone. And then it'll be a Webassign quiz that you'll do, and that'll count towards your quiz as the 15%. Okay. So, if there's a test in a week, right, whether it be Wednesday or Friday, there won't be a quiz that week. That would be too much. Rude. So, so if there's a test, then don't worry about the quiz. Okay. I have picked dates for the test. February 12th, right before reading break. And then Wednesday, March 17th, St. Patrick's Day. Fun. And then April 9th, nothing special. February 12th is my mom's birthday, but that doesn't really apply to you guys. But for me, all of them are kind of special. April 9th is after Easter. So what we'll do is we'll wrap up the material just before Easter, and then we don't have class on the Friday for Easter Friday, and then, or Good Friday, I guess it's called, sorry. And then we'll do a review once we're back on the Wednesday, and then we'll have the test on the Friday. So you'll have lots of time to kind of work on test 3. And you'll be submitting your work for quizzes and for tests, and of course the final exam. If I'm reading your work and I'm just kind of I'm not following what you did, or I need you to explain something to me, then I might contact you for a follow-up kind of post-exam interview, just for you to be able to explain, oh, here's what I did, here's what I was thinking, just to kind of, it's my right. It's in the course outline, so it's my right. Yeah. Can you read this to me? What did you write here? Yeah. What is this chicken scratch? Exactly. And I'm not one to talk because my writing is not that good, but especially after a month off. So like, um, will it get better? But not much better. Department policies are kind of dated because they're for in-person classes, but the most important thing is you have to get at least 45% on the final exam. So here, in order to be eligible to pass the course. Now, with the final exam only being worth 25% of your grade, it's totally possible for you to, not write the final and still potentially have 75% of the course. But with this condition here, you have to get at least 45% on the final in order to be able to pass the course. So even if you pass technically, you have to be able to spew out 45% of the course on the final exam, which has never been a problem. It was an issue one time. A student was super, super sick for the final exam, and they just, couldn't get quite that 45%. But of course, I'm reasonable, so it's usually not a problem. So it's not something to worry about. It is something to be aware of. There's no formula sheet, but all our tests will be open book. So just make sure that as you go through the course, if there are things that you find yourself kind of referencing often, then maybe have those on the side, kind of easy access for during quizzes and tests, right? Because I want you to use your resources. I want you to kind of feel confident with the material. But there's no formula sheet. Okay. So some important dates. January 22nd is next Friday, and that's the last day that you can kind of switch sections or drop a section and still get some sort of refund, I think, and it doesn't get recorded on your transcript. And then kind of free and easy until reading break, which is Family Day, and the week of Family Day, so February 15th to the 19th, there's no school, which we all probably are aware of and look forward to. March 12th, now that's pretty deep into the course, right? By March 12th, you should have a pretty good idea of where you might end up in the course. If for some reason you suspect that you'll be failing the course, you're better off just withdrawing with a W, because a W doesn't count towards your GPA. And so, and I only say this because you might be in your first year, and so maybe this isn't common knowledge. Once you've done a few terms of school, then that sometimes it's just strategically better to withdraw with a W than to get an F on your transcript. And then we've got Easter off, April 2nd and April 5th. which is awesome because usually Easter is just kind of messing with our final exam schedule when we just want to get out. But because of the bump in classes, we've got Easter break as well, which is pretty fun. So we will not have class on Friday, April 2nd. And then classes end April 16th. Somehow, with the extra week off, they still managed to end the final exams in the usual time. I don't know how they did. I think they just compressed the final exam period somehow. But I'm into it. My birthday's on April 30th. So when they first started talking about, oh, we'll extend it by a week, I was like, hey, am I going to have to work on my birthday? No, I'm still safe. So it's important. I've been teaching for 6 years now, and it's always ended right before my birthday. So didn't want to end that streak. Now I don't have to. All right, so some things to be aware of. There is the success centers. I think it used to be, what was it called? The Learning Center or something like that. Anyways, free tutoring. So people are hired by the college and you go to them with questions if you're not comfortable talking to me, or maybe you just need a different perspective. And I'm going to have Kate Sidlar from the Learning Center. She's going to come in and introduce herself and just kind of walk you through how to access it, because of course it's online. But it is free tutoring. And once we're back in session, it's a really good place to just go and work on homework or just kind of work on problems, because then you'll find other people who are working on the same problems and you can complain about them, and just kind of fun stuff like that. So something to keep an eye out for once we're back in session. Of course, I have to do the stern academic integrity. I'm actually gonna save it for when we actually have a quiz or a test, but I mean, we can police ourselves, and if you can honestly say that, yes, what I'm presenting to Emily is my work and my thoughts and my stuff, then you're safe, right? If for some reason you can't say that, then you probably have violated academic integrity. And so that's kind of the short of it. But like I said, we'll go through that closer to our quiz, which will be next Friday. Let's do one next Friday. Hey, there's nothing about the counseling on here. Anyways, there is free counseling. So if you're finding, you're overwhelmed, which is totally reasonable when we're working online and whatever, there is free counseling through the college. So if you find that you need that, then definitely you can reach out to me, but I'm by no means qualified, but happy to kind of put you in the right direction. So all right, that's the course outline. I haven't seen any questions. So, oh yeah, so the Webassign, we'll get that set up. We'll get it set up for Friday, and then I'll walk you through how to sign on. But if you've used it before, I'll just give you the class key. I'll post it on Moodle, and you'll have it. And make sure you use that free trial for the first 2 weeks. All right. So what I did was, because I want to, so usually I like to play it cool and not do any material on the first day, but because I want to have test 1 done before reading break, we're going to get right into 1.1, which is just talking about functions and all that kind of fun stuff. So if there are any administrative questions before we start, then let me know. Otherwise, I'm gonna just take it to, so like I've said on Moodle, and so I will have this set up for each week so you'll know what's going on. Today we're doing the introduction, done, and then section 1.1, and then on Friday we'll do 1.2 and 1.3. So no quiz this week because, well, we just started, so no thanks. And I also posted this 1.1, 4 ways to represent a function. So these are just kind of the notes because the textbook, of course, goes into way more detail, but here are the things that I want us to take out of this section. So I've kind of put together everything that you'll need from this section. And then if there are more things that you want to reference, then of course you'll have the ebook through the Webassign access and you can kind of read the textbook. But I know reading the textbook, it's kind of a beginning of the term thing, right? Oh, I'm going to read the textbook. It's going to be so good. And then, 2 weeks in, you're kind of like, I don't really have time to read the textbook. So and that's fine. So here, these notes that I post, you'll have everything that we'll need. Okay. So what I'm going to do is I'll pull, this kind of definition of a function, for example, and I'll write around it. And then those will be in the notes that we post. So, and we are just going through the examples, unless I find that there's a different type of problem. But of course, for chapter 1, there definitely won't be anything spectacular going on. So we'll just use the examples from the textbook. But sometimes I find that, one, the authors have chosen them for a reason. So they usually show a lot of different aspects. And I said one, but then I can't think of what my second point was. Anyways, maybe it'll come back to me. So let's go back into the notes. So section 1.1 is called 4 ways to represent a function. Now it's bothering me. I had 2 things I wanted to say, but I only said one. Oh, all right. So functions, right? You've talked about functions, whether you're coming from math. Is it 11 that you need for Calc 1, or is it math? Well, I guess I can answer my own question from the course outline. Whether you came from, hey, Math 12 or Math 120, if you took it here at the college, some sort of pre-calculus, good to know. A function is just when one quantity depends on another quantity, right? So functions arise whenever one quantity depends on another. Oops. So from the notes, I'm just going to grab the definition of a function, so we don't have to write it out. So a function, which we usually denote by F or G or H, we like to stick to that realm of letters, but I mean, you can denote it by anything you want, is a rule that assigns each element X, okay, in a set D exactly one element, which is f of X, so some output in a set E. So we've got this, so going from a set D to a set E. Okay. And so we've got kind of the domain is all the set, or is the set of possible inputs, and then the range is the set of possible outputs. So the domain D from above is all possible values of X which are inputs, and and the range, which above they called E, so some set E, is all possible values of f of X, which are your outputs. So all possible values of f of X, which is the function, okay, evaluated at X, which are the outputs. But of course, it depends on the domain, so all the inputs, right? So as X varies throughout the domain. Okay. Oh, that is some chicken scratch. So one thing that I want to kind of warn you about in calculus is it's going to be a lot of definitions. And I know that feels kind of overwhelming, but we need these definitions as kind of our rule book, so that we can develop concepts. So we will have a lot of definitions that we need to work through and just kind of establish. But once we have those, then we have the rules of the game, right? And then we can play the game. But especially in the beginning, it definitely feels like, oh, that's so many definitions. And I'll try to break it up as much as I can with, examples and problems to work through. But just kind of beware that it is a lot of definitions, because that's the foundation of everything that we're doing. So some notes. I guess these are all notes, so of course. We usually consider functions where the domain and the range are in the set of real numbers, right? Maybe with the exclusion of some illegal math. But we usually consider functions for which the sets D and E, the domain and range, are sets of real numbers. And from earlier courses, you might remember that this fancy script R is the set of real numbers. which if we want to talk about interval notation, right? Interval notation, the set of real numbers is just any number that we can think of. So when we say number, we actually mean the set of real numbers. And so the interval from negative infinity to positive infinity, that's the set of real numbers. Okay. And then there might be restrictions on there, but as a default, we're saying, okay, the domain and range are the set of real numbers. Okay. And so when we say something like f of x, right, I want you to read this. Read f of x. In fact, whenever you see something that has this layout, and this will serve you in if you take a stats course, so a statistics course, which is kind of more my jam. I don't know. Yeah, did I tell? Yeah. Anyways, I did my undergraduate in math, and then my master's is in statistics. So stats is kind of more my jam. But this is true for any field. But whenever you have kind of something on the outside smushed up against something in brackets, whatever is in the brackets you can read as of whatever's in the brackets. So for example, if you have g of a, right, you're going to read g of a. You can you can do weird stuff too, like cat of food, whatever. Right, so just kind of get in the habit of whatever's on the outside of whatever's on the inside. All this is saying is that whatever's on the inside is the input, and then the overall function at that input is the output. So if you have f of x, right, this here is the input, and then the function evaluated at the input is the output. Yeah. One connection that took me a while to kind of make, and if you've already kind of figured it out, and that's great, but whenever you see f of x, you can just as well read it as y, right? So if you want to just read f of x as y, if that makes more sense to you, if you're just working in an xy plane, of course that's the condition, but in an xy plane, which is where we'll be working for this course, right? So in an xy plane, which is anything like this, you can replace f of x with y. If you prefer. Okay. X is the input, y is the output. Okay. So that's just kind of some terminology around functions that we need to have a good handle on, and just kind of things that I find can be kind of difficult to grasp, at least in the beginning. So remembering that the domain is the possible inputs, right? There are some restrictions on the domain. I I was gonna go here, but I think before I do that, I'll save it for a little bit later. Let's go to example 2, where we're just gonna sketch a quick graph, mostly just to recognize different types of functions. So here we've got f of x. Whatever is the input has to be the variable in your function. If it's not, then that variable doesn't change, right? So only the input value is the thing that changes. So here, if you wanted to read y equals 2x minus 1, then it'll be more obvious to see that, okay, this looks like an equation of a straight line, right? Y equals mx plus b. So from pre-calculus, we kind of got familiar with some equations, some common equations, one of which is the equation of a straight line. And here we have a parabola. Right? So here has the form y equals mx plus b, therefore is a straight line. And then whereas here, this is a parabola. Okay. With no transformations on it. So it's just a quick parabola. You've got lots of things, lots of ways to sketch this graph. I'm gonna cheat and just use Desmos. But what you would do is you need at least 2 points on the graph, right, in order to graph a function. And so usually, you know, if you've got kind of an x squared, then you want to have 3 or 4 points so you can kind of see what it behaves like. But if you know you've got a straight line, you really only need 2 points. So you'd pick an input, right? You can pick some value of x, say 0, right? Then y at x equals 0 is 2 times 0 minus 1, so -1. That would be your first point, right? So you can find ordered pairs at different values of x. Okay. From here on out, I'm okay with you just using Desmos to be able to graph things. But just remember that, you know, from previous courses, you're expected to know how to graph. At least little stuff like that. Hey, that's what I did. How original. I picked a function from the examples unknowingly, subconsciously, probably. Right, 2x minus 1, it is unbelievable. Anyways, so here we've got our functions, right? Our x squared is the red one. So here I can kind of tap it, highlight it. I can even go through. So if you were drawing these things by hand, right, you could go through and find points and just make sure that they're corresponding with what you found. So if you don't have Desmos installed, right, you don't even need to have an account, right? I don't have an account, I just use it. So I always appreciate that. Too many accounts everywhere. But yeah, so even if you do graph it by hand, just check using Desmos to make sure that you're on the right track. So a parabola, right, we're expecting this kind of shape, no transformation, so it's definitely centered at the origin, and then it goes up. And then our straight line has a slope of 2 and a y-intercept of -1. So how do I, oh shoot, I'll have to figure out how to screenshot on here. It's a new iPad, so my other one clunked out. What didn't clunk out? The pencil. Anyways, it was a big annoying ordeal. But so here, I guess I'll just draw it out. I'll just sketch it. I've got the parabola here, g of x equals x squared, and I'll do it in green. I think it went kind of there. F of x equals 2x minus 1. Let's say this is at minus 1. Didn't do that very well, did I? There, that's better. Just a sketch, okay? Why I wanted to do this is, one, to remind you that, okay, we're still sketching stuff, but also from the graph, we can talk about the domain and range. Now, the domain is all possible values of x, right? So what's allowed to go into x? And then the range is all possible values of y. So for A, the domain is going to be what? So the domain for the straight line 2x minus 1, and you can get it from Desmos or from your own sketch, doesn't matter. This line keeps going and going and going and going, and eventually it'll span all the x's possible, right? So the set of real numbers from negative infinity to positive infinity. Now, it doesn't matter how you represent this, but you might remember something like x is in the set of real numbers. X is in the set of real numbers, right? Or if you prefer interval notation, negative infinity to infinity. Lots of different ways that we can represent the same thing. But especially in Webassign, they like to have you give answers in interval notation. So that's why I'm introducing that as well. So for the parabola, or sorry, I almost skipped the range. The range is all possible values of y, right? And so our y's for this straight line, well, if the x's keep going and going and going, then our y's will be spanned as well. So the range, I'm going to say y is also in the set of real numbers, right? Or negative infinity to infinity, whatever you prefer. Okay. For B, the domain, even though it doesn't look like it, one thing to keep in mind about a parabola is that it's actually going to keep going wider and wider and wider. And if you give it enough time, and it's going to take a long time, but it will expand to negative infinity and positive infinity. So the domain for a parabola, it's just good to have on hand, is the set of real numbers. So I'll just use interval notation, I guess. I'm dealing with a page break here, so I'm feeling like I gotta scrunch things up. The range, now here, the range, we don't go to negative values, right? If you square a value, it'll always become positive, right? And so the range is actually going to be just all possible y values, which are all positive in this case. So, and it includes 0, so that's one thing that you'd want to check. Can you have x equal to 0 in x squared? Yes, you can. And so the range here is including 0. So starting at 0, right, inclusive, and then it's going up to positive infinity. And just remember, infinity is not a number, so we always have a round bracket around infinity, right? Same thing here, negative infinity, positive infinity, we always have round brackets. Okay. Good. Good. Let me see here. Got kind of a lot of different notes everywhere. All right. So, working with functions, you might recognize something like this, the difference quotient. Usually not anyone's favorite thing to do, but we are going to use it quite a bit once we get into limits and derivatives. So that's why we make you do them in pre-calc or a lot of other courses. They're just a good exercise in working with functions. So let's see if we can work with functions this way. So if f of x is 2x squared minus 5x plus 1, right, and h is not equal to 0, the only reason we have that here is, remember, we can't divide by 0, so we need to make sure that h is not equal to 0. We want to evaluate f of a plus h minus f of a over h. Now here I'll just make a note. This is called a difference quotient, which will come up later, so that's why we're working with them now. So we've established what our function is, and here the only tricky part is we've got a plus h as our input. So wherever you see an x in f of a plus h, you have to replace x with a plus h. And then here, f of a, you just replace your x's with a. So I don't, whether you kind of construct f of a plus h and f of a on their own and then put them together, that's fine. I'm gonna start getting you in the habit of just kind of constructing them all on the same line, but it can get confusing. So if you find it confusing, then feel free to just construct them alone or kind of standalone objects and then put them together. So we want to have f of a plus h minus f of a over h. F of a plus h, I'm going to block it off with big square brackets, just so visually I can see where everything is. So f of a plus h is 2 times a plus h squared minus 5 times a plus h plus 1. End that square bracket. And then minus f of a, now I just replace any x with a, right? So f of a is a lot easier. In fact, I'm going to bump this down just a little bit. Whoops. So I can make notes above. There. No harm, no foul. This here is f of a plus h. And then f of a is 2a squared minus 5a plus 1. And then one thing I don't want you to forget is that it's all over h. Okay. What usually happens is you'll have to kind of expand and simplify the numerator. The numerator is the top value of your fraction, right? And so you'll have to expand and simplify, but eventually what's going to happen is the h is going to cancel, right? Or some h's will cancel with this h here, and it'll simplify quite a bit. So some kind of things to keep an eye out for, right? A plus h squared is a plus h times a plus h. So you'll need to expand that out properly, right? And so I want you to really kind of take your time and expand this. In fact, maybe give it a go. I'll work slowly, but just to kind of get used to doing math again, right? So remembering that a plus h squared is a plus h times a plus h. Here we go. Now, I can be a stickler for how you show your work, and it's not my fault. It's how I was raised academically. So, but just for proper math, you should be stacking your equal signs on top of each other, right? So when you read down a page, right, your equal signs should kind of stack. And I understand that that takes more paper, blah, 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 but it's the proper way of doing things. So whenever you can, just try to stack your equal signs. There are times when even I can't make it work, you know, page break or whatever, but when you can, just try to stack them like this. And if nothing's changing on one side, you can just leave it blank until it does change. Right? So these are all things that we'll get used to, or maybe you're used to already. So I'm going to keep these big square brackets just in case I need to go back and rework something. Something went wrong maybe. 2 times a plus h times a plus h. And maybe you're fancy and you can just expand this in your mind. Hopeless. I can never expand stuff in my mind. I have to write it out, and I do every step. And so I show more work than you probably need to, but it's all good. I will expand this -5 inside right away, right? So I'm just kind of simplifying things as they come up. -5a minus 5h plus 1 minus, and you know what? I'm going to expand this negative inside and get rid of these brackets right away, right? So it's kind of different levels of simplification here. Making sure you bring this, so just like the -5 went on the a and the h, right? You'll want to make sure that you bring this negative onto each of the terms inside. That's a pretty common math mistake that I see, where you forget, you bring the negative on the first one, but then you forget it on the second two, or the second and the third one. And it just wreaks havoc. 2a squared plus 5a minus 1, right? Once you bring that negative inside, all over h. And I know that you'll want to not write the h, but you have to. A lot of people just say, well, it just stays there, so I'm just gonna leave it out until the very end. No, 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 no. If you're telling me here, this is what I've got, then that's what you have to have on the right-hand side as well, right? You can't take liberties there. All right, so I've got 2 times a is a squared plus a times h is plus ah plus ah again. Even though it becomes ha, I'm just switcherooing them so I can collect like terms. Plus h squared minus 5a minus 5h plus 1. Minus 2a squared. Try to keep it on the same. Plus 5a minus 1. Got a little tight. Things will cancel and simplify and all that nice stuff, but till then. So I will collect the AH. So here I've got 2AH, and in the same move, I'm going to bring in this 2 and multiply it inside. So 2a squared plus 2 times 2AH is 4AH plus 2h squared. Minus 5a minus 5h plus 1 minus 2a squared plus 5a minus 1. Sneaking it in there. Over h. Now, these brackets around my f of a plus h aren't doing anything. So what I can do is I can just, right, there's nothing outside here, so they're not doing anything. So what I can do is I can just start cancel. Whoa. Oh, it's this fancy, I'm not used to this pencil where I guess if you double tap, it'll switch to the eraser. Gotta be careful. Might even have to turn it off. Erasing stuff. So 2a squared minus 2a squared, that's going to go away. Negative 5a plus 5a, that's going to go away. And then plus 1 minus 1, so that's going to go away. Okay. To show the cancellation, I'll use a different color here. Notice that the terms that are left over here all have an h in them. So like I said, when you're working with these, more often than not, this h is going to cancel out, right? There's still going to be h's up in the numerator, but this h in the denominator is going to cancel out. One way or another. So you get 4ah plus 2h squared minus 5h over h. Okay. Remember, so some common mistakes I see or illegal math that I see is if you just cancel with one of these terms, an h here, you have to pull out a common h from every term in the numerator, right, before you can cancel. So for me, just to highlight that to myself, I like to actually physically pull it outside. You don't have to. You can just go through and cancel one of each h with this h in the denominator. But just to emphasize it, I'm going to pull out an h here. So 4a plus 2h minus 5 over h. And then I'm going to cancel it. And that's just a way to kind of check myself. So now what I'm left with is 4a plus 2h minus 5. And that's it. So, so much work, right? But it is really satisfying. It blows up huge, and then we shrink it down to something really bite-sized. So here, right, in this example, we just used it as an exercise in working with functions and manipulating functions. Later on, we'll use the difference quotient. So we will get really good at working with difference quotients. Okay. But we just do the same thing all over again. Okay. Good. So let's see here. Oh yeah, I wanted to move this up to the top, but then I ran out of time. So there are kind of, there are 4 ways that we can represent a function. Kind of less common is verbally, right? So I can tell you a situation and I've got an example. The storage container. We love these storage container questions, right? How do you minimize the cost? How do you maximize the volume? That kind of thing. So why not? Let's get used to a storage container question. So we can describe functions in words. We can give a table of values. I think that's kind of a little bit beneath us at this point, right? We've already talked about functions like here, right, numerically. Algebraically, I should say. but also visually, in which we've already seen. So we've seen all these, but as an example of a function that's represented verbally, we'll do that storage container example, which is on here. And I might just sneak, oops, try to include the box too. Although I do feel like I can draw a pretty good box. I'm not very good at drawing anything else. And 3D boxes, well, should be easy, but I don't know, they're not for me. Anyway, well, so one time I decided to make a dog crate for my dog. And so I wanted to build it. And of course, I was kind of sketching things out. And I was showing my sketch. And it totally, like, when I came back to the sketch, it looked just completely wonky. I'm sure I took a picture, but I'll see if I can find it just for an example of how not to draw 3D boxes. Should be easy, but it's not. Anyways, so here we've got a function. The information is given verbally. We're going to convert it to an algebraic function. So here, function is given verbally. Maybe I'll put air quotes around verbally. It's written, it's not verbal. Function is given verbally. And we need to convert it into an algebraic function. Okay. So a rectangular storage container with an open top has a volume of 10 meters cubed. Okay. The length of its base is twice its width. So here 2W and W, so we've kind of got a jumping off point. If you didn't have this graph, of course, you would have to kind of arrive at that on your own, which can be tricky, but it's our first day, so giving you the box. Material for the base costs $10 per square meter, and material for the sides costs $6 per square meter. And we're going to express the cost of materials as a function of the width of the base, so as a function of the W. Okay. So our input is going to be W. Express the cost as a function of W. Right, so here, we can denote it as C of W. Usually for cost, we use a capital C, and that's pretty across the board. So we've got C is the cost, and W is the width. Okay. So we're trying to find this function C of W from this verbal description. Now, one thing that you'll kind of run into, right, eventually is, okay, fine. So the base, we know how to find the area of the base, and we know the cost of the material per square meter. Fine, 2W times W, all right. The tricky part comes in when we have to incorporate H. So that's why we have this additional information, and that's going to be a common theme of these problems that we're solving, right? And so it's usually going to be a two-step problem or more, right? It could be a three-step problem, but just be aware of that, right? So even though the 10 meters cubed in volume doesn't seem to play a role, we're going to use that to rewrite h in terms of w. Right? So here we go. So let's start with the base, and then for the cost of the materials, we can just add the cost of the base plus the cost of the sides, right? And so C of W we can write as the cost of the base plus the cost of the sides. Okay. So I'm going to tackle these individually, right? I'll do the cost of the base and the cost of the sides. So I'll start with the base. And there's lots of ways that you can work your way through this problem. Right? You can kind of talk your way through it. But however you decide to tackle it will end up at the same function. So there's lots of ways that you can solve this. But for the base, the area of the base is going to be 2w times w squared. Or sorry, times w, which is 2w squared. Right? So then the cost of base, we said was $10 per square meter. And of course, that area depends on W, which is what we wanted, right? We want W to be the input. So regardless of what W is, we can figure out what the area is. So I'm going to say that's $10 times 2W squared. I'm going to ditch the units, right? I just want to highlight that that $10 is the dollar amount. But from here on out, I'll just kind of, I'll add the dollars on maybe at the end. I'm not too hung up on units. I tend to forget about units. I know in chemistry and physics, even biology, units are super, super, super important. In math, we'll get there. So here, the cost of the base, if I expand this in, right, is going to be 20w squared. Okay. Now I'm going to deal with the sides, right? For the sides, I've got 4 sides, right? 2 kind of long sides and 2, let's say, short sides, at least from this image. So I've got 2 sides that are h times 2w, right? And then I've got 2 sides that are h times w, okay, for the area. And it has an open top, so I don't need to worry about the top. Okay, so for the sides, it's a little bit more work, right? So let's kind of go there. The area of the sides is going to be 2 times that first one, h times 2w, plus 2 times w, h times w. Okay. That's the total area of the sides, right? We have 4 sides. So here, this 2 and this 2, 4 sides total. Okay. So now we're pretty good at expanding things like this, right? So I get 4wh plus 2, and then I'm going to write WH again, just so I can see that these are like terms. 2WH, which is just going to be 6WH. Now the cost of the sides was $6 per square meter. Now the square meters here is 6WH. Okay. The cost of the sides is $6 times 6WH. One problem here, oops. We need this in terms of H, right? Or W. I read the H and said H, classic. Need this in terms of W. Okay. So we need to do a little bit more work, but we can simplify this first, right? 6 times 6 is 36. So I get 36 WH. Okay. So we need to find H in terms of W. We need to find H in terms of W. Right? H as a function of W. So we're given that the volume is 10 meters cubed, right? I think it was something nice and clean. Yeah, it has a volume of 10 meters cubed. Now remember, the volume of a rectangle is going to be the height times the length times the width, right? So H times L times W, I guess. So I can replace the volume on the left-hand side with H times the length, oops, times, I keep screwing this up, times W is going to be 10, forgetting about the units for a little bit, forever. So H is H times 2W times W is 10. So what I have, right, is I have 2HW squared, or if I'm solving for H, right, I'll probably just do 2W squared, and then I can divide that over. So solving for H, I get H is 10 divided by 2W squared. So now I can simplify this. 10 divided by 2 is 5, right? 5 divided by W squared. So H is 5 divided by W squared. So now I can take this H, right? And I can plug it in place here, right? And it's gonna simplify things a little bit. So then what I can say is, therefore, the cost of the sides, which was 36 WH, is 36 W times 5 over W squared. Now, I'm not very good at math, ironically. In my head, I'm actually terrible at math in my head. And I blame a math degree. Because you use your calculator so much, towards the end of my math degree, I caught myself doing 1 + 1 in my calculator, just to make sure that it was 2. So I don't know, you start doubting yourself. But anyways, I'm okay with it. 36 times 5, I'll just do it in here. And I don't expect you to do math in your head either, so there's an upside. 180, although it's always good to be able to. Right, I'm just multiplying across here and dividing, so I can just go across the brackets here. So I get 180, and then here, this W, I can cancel with one of these W's, right? So what I'm gonna do is I'm just gonna show that here by crossing out this 2 and crossing this one out. So it's 180 over W. Okay. Nice. Hey, that's it. The cost of the sides is 180 over W. Just depends on what W is. That's great. So now we have a simplified version of the cost of the sides. See, it's lagging a little bit there. So 180 over W. Now, that's in terms of W, that satisfies the criteria. So now I can put this all together. And so the overall cost, C of W, is the cost of the base. There is the cost of the base plus the cost of the sides. So now I can put this together and then I'll be all done. So C of W is the cost, and I'm just going to write it out again because there's no harm in that. The cost of the base plus the cost of the sides. The cost of the base, now I can't even remember what it was, 20W squared. Okay, so I'm just going to put that in. Plus the cost of the sides, which we just established was 180 over W. We could probably simplify this a little bit and get them over a common denominator. I'm not going to do that. I'll just leave it like this. Okay. And the only condition is that W has to be greater than 0, can't have a negative width. That condition kind of goes without saying. So if you didn't include it, then that's totally fine. But just to be proper, we should have it in there. Good. It also avoids dividing by 0, right? If the width has to be greater than 0, yeah, that would be a trick. Kind of negative widths. Yeah, magic. But it also avoids dividing by 0, right? So part of the domain that we need to check. But here, because our width has to be greater than 0, we're fine. Okay. Let's talk about the domain, and I think that's good for today. But let's just review the domain before we go. So here, I guess I should show that it's the end of a question, end of the example. I'm really bad at showing that the example's ended. End of example. I don't know. I'll try, but let me see here. Where did I want to take this? Oh, yeah. The domain. There are 3 important things that we need to keep in mind for the domain. And it yields illegal math if we divide by 0 or take the square root of a negative number or take the log of anything but a positive number. So I'm just going to outline those rules and then we'll come back and we'll start the example with the domain on Friday. Example 6. So there are 3 things, 3, I'll say, important things to remember about the domain of a function. Right. First one is we can't take, or we can't divide by 0. I'll start with that one. We cannot, divide by 0. Okay. So even if you tried it on your calculator, right, if you did 4 divided by 0, it'll tell you that it's undefined, right? Because you can't do it. So 2, we can't take the square root of a negative number. If we did, or if we had to, we'll get into imaginary numbers, and that's not for this course. So you can, it is a field, but it's not for us. So we cannot take the square root, or sorry, I'll expand this, take the even root, right? Square, 4th root, 6th root, 8th root, okay? So I'll even expand this, take the even root of a negative. In the third one, we cannot take the log. We cannot take the log of 0 or a negative number. Of 0, I guess it should be nor a negative number. All of these, right? If we did do these we call illegal math, or I call illegal math. If you're trying to divide by 0, or most common trying to take the even root of a negative, can't do, that's illegal math. So just to kind of, I guess I've got the negations here. Anyways, I think you get the idea. Okay, so on that note, you've got the example for next day, and that's where we'll start as kind of a review. So I encourage you to kind of try to work through that, and then we'll pick up there on Friday. Are there any questions?
Just to refresh, we're handling all the Webassign stuff also on Friday?
Yeah, I'm going to put that off till Friday. I'll get it set up, and hopefully it'll work better this time. Awesome.
In that case, have a nice day.
See you Friday. Yeah, you too. Yeah, so this log is log of any base. So log base E, log base 4, totally. Awesome. See you Friday.